Lesson 54 is on velocity and acceleration, and again there's a note sheet on Schoology if you'd like to print it. And if you are in physics, you are probably pretty familiar with this, so hopefully there's a lot of review for you here. First of all, definitions. The position function we're going to call x of t. It measures the distance from the origin with respect to time. That essentially is the location. Velocity, v of t, it is the derivative of the position function. It's the rate of change of position with respect to time. And velocity has both the speed and the direction. So it'll have a positive or negative in front of it. If the velocity is greater than 0 or being positive, it's going to move to the right. If the velocity is negative or less than 0, it moves to the left. So very similar to a number line. The acceleration function is either the derivative of the velocity or the second derivative of the position function. And it is the rate of change in velocity with respect to time. And just like velocity, it has direction as well. So if the acceleration is greater than 0 or positive, it accelerates or it speeds up, and that's in a positive direction. If the acceleration is negative or less than 0, it decelerates or speeds up in a negative direction. So again, it's positive or negative. We have direction on that. A few things to keep in mind. So first of all, position function graphs position of an object, not the path. So for example, if you are walking home and you start here and your house is here, if you're walking home, you would walk this way. Okay, that is not the position. The position is the distance right here. This is the position. It's not the path that you walked. Velocity, an example of velocity is walking to a house or away from a house. So again, if your house is here, if you walk towards the house, it would be positive. If you walk away, it would be negative. And acceleration is how fast something changes and the direction. So if it is accelerating, it is speeds up in a positive direction, but the decelerating speeds up in a negative direction. So we have direction with that. Okay, so we're going to start with a basic problem. We have a position of a particle that's moving along the x-axis at a time t, and it can be represented by this function. We have to find the the position, velocity, and acceleration when t equals 3. Well, we have the position function, so for the first one, all we have to do is take and plug in that value of 3. Don't forget your parentheses here. And when we plug this in, looks like we're at negative 13. And we don't have units on this, so we're just going to call that negative 13 units. And this is the position function, and position functions are not squared or cubed. The next one, we need to find the velocity when t is equal to 3. So to find the velocity, we are going to take the derivative of the position function. In taking the derivative, we get negative 6t plus 4. And when we now plug in that value of 3, what we get is negative 14. And this time, this is units per second. Because it is a rate, that's why we have units per second. And then when we're finding the acceleration, that is the second derivative of the position or the first derivative of the velocity. So I'm going to do the derivative of the velocity. So a of t is going to be the derivative of that velocity function, which is negative 6. And that is units per second squared, because now this is the units per second, but then it's another per second because it's a rate of change. So that's pretty basic. That's finding the position, using the position, velocity, and acceleration functions. All right, getting into a little bit more detail here. If I have a position function that is this right here, I'm asked to find these 5 different things. The first one says when the particle is at rest. So when the particle is at rest, the position is not moving. So we have to take the position function, so x of t, and we just set it equal to 0 and solve. So 0 is equal to t squared minus 3t plus 2. And this looks like this is factorable. It's t minus 2 and t minus 1. So what I get is 2 seconds and 1 second. So at 2 seconds and 1 second, the position is not moving. It is equal to 0. And then it says when the particle is moving to the right. So when something is moving to the right, that is based upon the velocity function. And because it's going to the right, that means the velocity has to be greater than, has to be positive, so greater than 0. So I'm going to find the velocity of this, so the derivative of the position function, so 2t minus 3. And if I now take and set that equal to 0, you can see what I get is 3/2. So at 3/2, it's not moving to the right or to the left. So if I want to know when it's moving to the right, I want it to be positive. Well, that's going to take place anytime the time is greater than 3/2 seconds, or 1.5 seconds, because that's when it's going to be positive. Now, when it's moving to the left, that's where the velocity function has to be negative. In order for this velocity function to be negative, I have to have a value that's going to be less than 3/2. So this is going to be where t is less than 3/2 of a second. And now we're looking at acceleration. So acceleration is the second derivative of the position function, or it's the first derivative of the velocity. So it's definitely going to be easier to find the derivative of the velocity. And this right here is going to be my a of t. And that is equal to 2. And this is a positive value, so the particle is always accelerating. There's no constant right here, so this is not going to change. So it's always accelerating. And when it's decelerating, well, it never is, because this 2 does not have a variable attached to it, so it can never be negative. It always has to be positive. Right, the next thing we need to talk about is gravity. And the acceleration due to gravity is either negative 9.8 meters per second squared or negative 32 feet per second squared. And you probably have learned that if you are in physics. So if we have the Earth's surface, say it's right here, anytime we're moving away from the Earth's surface, it is positive. Anytime we're moving down to the Earth's surface, it is negative. So let's do a problem that deals with gravity. So we're throwing a ball vertically in the air where the height in meters is a function of time. So this is our height function, or our position function. And you'll notice right here, there's our gravity. And that's why it's in meters, because it's negative 4.9 meters per second squared. It says to find the height and the velocity at t equals 1 second. Well, the height is just using the height function and plugging in 1. So that's just finding h of 1. So when you do that, you 1 squared, you just get 1. That, you get 20. It looks like what we're going to get is 17.1, and that's in meters. So that's our height at 1 second. The velocity, again, has speed and direction. So we're going to find v of t. So we'll find the velocity function first, and then we'll plug in the value of 1. So we're going to find the derivative. So we have negative 9.8 t plus 20. And what I'm finding is v of 1. So I'm going to plug in 1 right there. So negative 9.8 plus 20. And when we evaluate this, it looks like we're going to get 10.2, and this is meters per second. So it's positive, it's moving to the right. The next one says, at what time is the height the greatest? So if you think about the height, if a ball is thrown up and then comes down, the highest it goes is right here at that turning point. And we also know that turning point right there, the slope is equal to 0. So if we take our height function and we find the velocity, the derivative of that, and set it equal to 0, we're then going to know when we have a maximum. So we already took the derivative right here. We said it was negative 9.8t plus 20. If I now take and set that equal to 0, I get negative 9.8t is equal to negative 20. When I divide both sides by negative 9.8, I'm going to get 2.04 seconds. At 2.04 seconds, I'm at my maximum right here. That is the time in which the height is the greatest. The next question says, how high will the ball go? Well, the ball can only go to where the maximum height is, right here. And we know the maximum height happens at 2.04 seconds. So if I take my height function and I plug in 2.04, so h of 2.04, that right there will tell me what the maximum height is going to be. And if I plug that into my calculator, what I'm going to get is 22.41, and this is meters. The final question is the greatest value of acceleration. The greatest value of acceleration. So the greatest value of acceleration, we have to take the second derivative, obviously, for the acceleration. So let's find v of t. So it's the derivative of this. The derivative of that is negative 9.8. And of course, this is meters per second squared. Well, that is our greatest value of acceleration, and that is due to gravity. Okay? Anytime you have gravity involved in this, your acceleration is going to be your negative 9.8 meters per second squared, or if it's in feet, it'll be the negative 32 feet per second squared. And I just realized up here I said negative 4.9, that's due to gravity. It is, because when you take the derivative, you get your negative 9.8. So I don't think I said that correctly before, but that you're going to constantly see that either negative 4.9 or the negative 16 if it's in feet. And actually, I think I missed a question here. I think you have on yours, when will the ball hit the ground? And if you don't have it on yours, you should write it, because this is important, and this is a common mistake in which people don't know which equation you have to use. So when the ball hits the ground is when your position function, your height function right here, is at 0. Because think of, again, about a ball right here. You're throwing it up like this. Well, when it hits the ground, the height is at 0. So what you need to do is take that height function, so negative 4.9t squared plus 20t plus 2, and set it equal to 0. And for this particular problem, you're actually going to have to use the quadratic formula. And I'm not going to do it, but I will tell you what the answer is. It is 4.2 seconds. You get a positive and a negative 1. And obviously you have to throw the negative 1 away because you can't have negative time. So 4.2 seconds is when that ball hits the ground right there. Okay, lesson 54 homework. There it is. Have a great day.